Hello, 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 everyone. Welcome to today's Water Cooler Chat, where we talk about all things Livepeer, whether it's delegating, orchestrating, gatewaying, AI inference, transcoding, anything to do with the Livepeer ecosystem. We're here to ask questions and get answers. So today, we got a couple topics ahead of us. I'm actually going to be slightly talking as if we're going to do a notebook LLM re-recording of this using the Google LLM that converts this meeting into a podcast. So you might hear me just explain more in depth about things just to see if the podcast can pick up on it. So we got a couple topics ahead of us. We got the AI pipeline. We're going to talk about the service URI registry for transcoding versus AI, tickets for jobs failed, when do cold models get loaded, how does that affect the cold models once they're loaded, feedback for the Livepeer AI docs, as well as demo day and some other updates from the Livepeer team. So let's get ourselves kicked off with a couple topics. I think we can start off with the this is going to be a pretty technical meeting today, so I think we can start off with right with the AI pipelines and the service URI registry for transcoding and AI jobs. So in the orchestrator chat, there was a conversation around merging the Livepeer AI kind of subnet into the main branch of Livepeer, and I guess there's kind of a divide, at least in the small discussion I saw, around whether we should also merge the service URI, on-chain service URI for transcoding and AI. Right now they are separate. So if you want to, get in your discovery request from gateways, if you want to see which AI nodes are on the network, you have to go to one service registry contract and get a list of all the orcs. And if you're doing transcoding, you would do a separate one. And there has been a conversation around merging those two, so you only have one entry point for the discovery request. Does anyone have an opinion on kind of whether we should merge those things or keep them separate? Anyone want to kick us off?
Can I just chime in on an idealistic stance and perspective?
Yes, go ahead.
Um, that I do think that as a protocol and network that with many varied capabilities beyond just transcoding and with the AI jobs also widely varying amongst them, rather, that it seems like I feel that a unified kind of gateway to Livepeer as a networking protocol would be what I would expect from a developer standpoint. And from the outside, I don't see why, like from a non-technical standpoint, why they would necessarily be bifurcated in this way. Though, as an orchestrator, I see your guys' perspectives that I've seen in the chat, and I think that I'm not sure that there really is a technical limitation that would prevent us from making both sides of this happy. Giving you, Titan as an orchestrator, the ability to coordinate your AI specific routing to separate boxes and separate ports, etc., but yet expose one service URI for gateways to discover your network of tools, orchestrators, transcoding, and AI nodes as well.
So just to reiterate, you're saying from a gateway's point of view or from a developer's point of view, it makes sense to have one entry point to deal with, and abstracting out multiple service URIs for each different service that Livepeer offers becomes unintuitive.
Yeah, kind of just my knee jerk reaction. Maybe it's idealistic, but that's
Those
where
of
I'm
us
sitting.
that say for those of us that haven't seen the discussion, what's the argument to keep them separate, or what's the not argument, but what are the thoughts on keeping it separate? Why? What's the advantage to that?
So I guess I'll it doesn't really matter to me because I will probably just use the Livepeer router to reroute things anyway. So there's ways around it. But the what I was thinking was the infrastructure from an orchestrator perspective, the infrastructure for running transcoding work and the infrastructure for running AI work are pretty unrelated. They don't cross over quite well. For instance, if you're doing transcoding, you might value proximity and speed and jing discovery requests and feedback and where the streams go through are very critical. Whereas with AI work, you might not geolocation might be such a low priority because maybe you need a cluster of GPUs or a cluster of H100s all in one location, and so all your orchestrator requests are going to go to one side, one location, regardless of where you are in the world. So like there's like a geolocation difference based on infrastructure, build out. And so therefore you would want the gateway not to use the same discovery point because it's different. That's one example. Um, yeah, that's basically the example I think.
If I can just chime in on that specifically, I'll add that the AI jobs themselves, potentially, I could see them having separate routing and requirements. You have different nodes that you want to run certain models on. And so say you have, some number of machines running and set up to do Flux, and that's a big, GPU, RAM, VRAM heavy model. And you need that as part of your infrastructure separately configured and routed. You want it to address the whole world, but you have some SAM2 models that are much more lightweight, and you have one in numbers of regions. So what I'm seeing is the same argument that you're using to separate transcoding from AI jobs as applying potentially to individual AI jobs themselves, or rather different AI workloads. And so with that in mind, I'm kind of thinking that this kind of differentiation is going to have to happen anyhow. We're going to have that kind of capability. And so I'm not sure how transcoding is different than just another AI workload in that kind of framing.
Yeah, I mean, I already handled this problem with transcoding through Brad's Livepeer router, where I just simply map, I send the stream to a specific orchestrator based on proximity, and that's all done through the router, right? And so the router is just one entry point, and once you do a discovery request to it, it just goes, "Hey, listen, you know, based on your request, go to this orchestrator." And so that can easily be done on the orchestrator side. So I don't have a strong opinion on this. I'm just wondering, like, is it technically, would it be better to just have one service URI registry contract deal with? Um, is there an opportunity to add a second endpoint to that one contract? I guess I'm just kind of curious, like from the gateway's perspective, would you even notice a difference between calling upon two different registries for two different discovery requests? Like, would you even notice?
I'll admit this is kind of an implementation detail to the extent that I don't think that other than as operators and well, and developers potentially. I'm not entirely sure of all the implications, but
Right.
yeah,
This is more of an implementation detail, and how do we want to set forth the precedent for how we do routing of jobs and add new services. Like I can see how this could spiral out of control if Livepeer moves on to adding more and more services. Then are we stuck with using this like 10 different service URIs for each different thing, and we really just consolidate that?
yeah, that's where it becomes untenable. And I think that splitting or maintaining two separate ones is a path to what you're describing, and that's not ideal.
Yeah, because you could easily just set up a Livepeer router to receive them, and then the org gets full control as to like, where do you want this to go anyway? Let the org decide their infrastructure, not the
Right.
protocol.
Off chain, there may be some type of on chain capability registration with these additional job types, but I think that maybe orchestrators handling them off chain, as you're describing, is the route forward.
When gateways send their discovery request for a particular job type, I'm assuming they're also sending metadata that includes what they're asking for, right? So whether it's a transcoding job or a AI job and which model, like all that information is sent with the discovery request, correct?
I'm not going to offhand say 100% of it, but yes, there is a specific subset of information that describes that request uniquely for the job workload type.
Because I think Brad is pretty deep dived into the router. But from my understanding, the transcoding jobs don't actually send what they're trying to transcode. They're just getting a assigned, like a assigned parameters that they're responding. They're live. Whereas I think the AI jobs, I think they are sending like the request of like what the actual model is, so that the orchestrator can decide if it can reply, right? Again, like I think this is like a small implementation detail. I think I don't have a strong opinion either way. I'm kind of curious from a developer and maintenance perspective, what would be best for the protocol. And it sounds like, I know Doug expressed that it would be best if we just had one on-chain service URI, and then from there orchestrators can pick out how to handle that.
And to your point, Titan, I wanted to add, yeah, I think both in the case of transcoding and AI jobs, we use a capabilities check. So the Livepeer router does forward along based on requests based off the capabilities the orchestrators have behind it. So I would suggest the Livepeer router might be a good solution, and I think that can benefit the network overall if we made that more mainstream. And we're currently, I think there may be some changes that are not merged into the main branch that we could bring out and document, because that really helps with like geo routing, but it also in this case would help us work with like a capabilities list.
Yeah, definitely. Yeah, I'm just trying to think like the initial implementation. Like the way I'm going to be set up is I have 7 orc nodes that do transcoding, and they're all proximity based, where Livepeer Inc. has their ingest nodes. But for the AI subnet or for the AI work, I won't be doing any geolocating. I don't think there's actually a benefit to it. So rather, I'm going to be setting up a standalone O somewhere, and for every AI GPU that I want to attach to it, I'll just attach it remotely. Therefore, kind of the pipeline between the two on my setup. So what happens now is on my 7 routers I'm running, I now have to just like redirect all AI jobs to the to the one standalone O AI node, which I don't think will be very hard. And then, because right now it's set up that it's this totally separate registry, totally separate registry list, and I just get appointed there by default. So yeah, it just requires, I think, people to set up a router, something, because the other question is, if you are doing transcoding work, sending transcoding work to port 8935, and you're also sending AI work to port 8935, would there be any conflict in that sense? Or would it be fine just using the same port for do two different services and not gonna make it?
Yeah, I think that would be the aim, is that GET orchestrator requests would be able to come through the same port for both AI and transcode, and use the same host name as well. Yeah, and the capabilities check would just drive where to route the traffic. Even more interesting is at the orchestrator level, if we took the router out of the picture, how could because we have the remote AI worker that's under development. I'm not too familiar with how that works, but we may be able to scale at that level already once that gets merged.
Okay, interesting. Yeah, I mean, all we have to do, like, basically, the router, I think, would fix this problem. We would just have to merge the router into the main base and build tests for it. So
Yeah,
a lot of
totally support that. That would really help, and I mean that would help the network overall. I've been using the Livepeer router since about February, and it's really helped me scale nodes, and it creates sort of a pool concept. So if I wanted to bring on another orchestrator or a transcoder, we can set up a dummy orchestrator node, add them to the router, and it's kind of makes it very easy to make a pool. So yeah, I think that'll help the network out a lot.
Yeah, I think just deploying and updating the router on-chain server conversation. Basically, have one place on-chain, that's your registry, points to a router. The router then directs which orchestrator node it goes with. The traffic, the actual traffic is going to go through, and your orchestrator traffic goes through that node, and then whatever's behind it are your connected Ts, connected GPUs, connected AI services, AI workers. And then from a gateway perspective, left with just one service URI, and you just got to hit that one endpoint, and you're gonna get a response. Just to read some of the comments, Heterotic says services with different use cases need to be identified with some kind of registry, but if the registry is accessible for multiple services, then requests have to refer to a specific service. If the general case permits this info passing in the request, then you can use a single endpoint, right? Otherwise, you would need to route requests to specific endpoints. Certification for a particular service, different schemas. Better to have registries of certs in the receiver endpoint than the sender config. Then again, this means the request message still needs to specify. Yeah, I think the capabilities request is where. So as long as the capabilities request sent during the discovery request, then that'll be enough information for the operator to manage what applied with. Nico's remote AI worker is scalable like that. Tested it for 2 months already, running one central O and connecting each GPU as a remote worker. Yep, that's excellent. Great. So yeah, again, you just have the one central O and then GPUs remote. Interestingly, this could be abstracted to a separate layer, aka roll-up of certs. The router should be orchestrator then it should assign a work to transcoders accordingly. Orchestrators should be orchestrating that. The only thing is, the orchestrator is the one for receiving and sending the traffic. So it is public. It has to have a publicly accessible endpoint. Whereas transcoders and AI workers, you don't typically want them to be pingable or accessible to public network. So orchestrators are kind of orchestrating by actually receiving the traffic and sending it back, keeping all the workers behind it kind of hidden and protected. And then the router is just like how to handle job types on the network. That doesn't actually touch any traffic, just literally fixing this problem around multiple service URIs. This is also a feature in the AI video branch. Waiting to merge them. Tired of building Docker image itself. Cool. Any other comments or questions around that implementation of binding service URIs into one endpoint? Yeah. It sounds like most people are interested in pushing it forward. I don't think there's a strong pushback on it. Hypothetical.
So I really want to point out again that there's this huge opportunity there. We're talking about we want the AI endpoints and the transcoding endpoints to be secure. We can provide the information to the orchestrators via rollups, which can be ZK. That secures the endpoint information in the transmission registry data so that the orchestrators can communicate about endpoints and provide services on those, but having the public in secure rollups so that traffic can be monitored and maintained on the network by some kind of regulator, but each individual orchestrator can basically manage their own service registry presence, if that makes sense. This is a good development. I would strongly encourage everybody to point at a single endpoint API, but just keep in mind that means you need a layer of abstraction in order to route all those requests, but that could actually be a separate layer service. Anyway, thanks.
Yeah, no worries. Yeah, I guess the question just becomes, does that routing of the request after it hits the endpoint need to be on chain or off chain? And think it at that point it can be off chain, so it can be dealt with however the orchestrator wants. Or you could implement some sort of like on chain method, doing all the abstraction layer. I don't know how that works. Yeah, no, it's an interesting point of view. Cool. Okay, let's continue on. We'll continue this discussion in the orchestrator channel. I'm sure of it. I don't too much pushback. Papa Bear, your topic is around. You got 3 topics: tickets. So tickets for failed jobs. When do cold models get loaded? And once the cold models are loaded, what happens then? Why don't you kick us off with your topics and give us a little more in-depth insight into what you're thinking?
Well, I mean, I think the multiple tickets thing is kind of baked into it's the way Livepeer works, with the way it exchanges tickets between the orc and the gateway. So I'm not sure like what could be done there, because again, I don't know how much it would take to make some sort of system where, I mean, it just, I don't know, it just seems very wasteful. And as a user, I wouldn't want to be paying out, potentially, paying out for jobs that are failed jobs, especially not multiple ones in a row. So it just seems very inefficient that an orc sends a ticket with I mean, with a job. But I understand also that's the way it works, is orchestrators aren't going to work without any like guarantee of pay. So since that happens before the job happens, I don't know. I don't really have a solution to it, but if someone does, I'd love to hear what it is, or any suggestions around how to really just kind of create or get rid of the waste on that, or the inefficiency there. And part of it also is that, again, if you have a bad actor, it allows them to take advantage of the network by saying that you can do these jobs and then not being able to complete them, but still getting the payment for them. So it's kind of a security issue in a sense.
So are you saying,
that's
just to clarify, are you saying that
yeah.
obviously the tickets are sent before the job gets started, because an orchestrator wouldn't do the work unless it
Right.
gets paid. But then after the
That's
tickets
my
are
understanding,
received, basically the orchestrator is just replying with, no, I'm not gonna, I either can't do the work or I'm not gonna do the work. But by then it's already cashed the ticket.
No, I mean they have to already, like, they already like are advertising that they can do the work, but there are times where jobs fail. Actually, I mean, it could be for many different reasons, but it's not uncommon to see, especially with testing, where if where we'll continually send a job to the same orchestrator to see if they can complete the job. So it wouldn't happen as so often that it's going to go multiple tickets in a row to the same orchestrator, but you could send multiple tickets to different orchestrators that don't complete the job for whatever the reason, whether their response time is too slow, or they just fail for I mean, this could be, I mean, there's lots of different reasons, but I'm kind of blanking on what the reasons might be right now. But it's not uncommon for a job to fail. So I mean, it's the same thing with transcoding. It's always been an issue where you're paying for the work in advance, and if they don't complete, there's no refunds basically. So you're paying in good faith as a gateway. So yeah, I just don't know if there's a better solution than you say you can do it. I trust you can do it. Here you go.
Doesn't the orchestrator after the request is processed and it generates all the pixels needed for the video or the image, it calculates like how much you have to get paid, and that's how it's like connecting to the gateway for payments? Isn't that how it works? Because
I
there is
think it
like
actually
a
happens
number.
before the job is sent.
Yeah,
Well,
that's
in the code, I think there's like a there is a in the code there is a part of the code that says like what's the total number of output pixels from the orchestrator. That should be after the process is done.
Papa
After
Bear's
the
correct. It
generation
does
is done.
happen
Well,
beforehand, like transcoding does.
yeah.
And I know that it is on the roadmap to come up with a better solution there. That's for many of the reasons that you've pointed out.
Okay. Okay. So it's all right. That's really what I was curious about it. So there is potentially a solution coming. That's good. Um, and then with I was just kind of curious more about cold models, how they work. Like when do they get loaded? Like if an orchestrator gets picked, or during the discovery process, or does anyone know that?
I could speak to it a little bit. So there is like there's a warm pool and a cold pool within the gateways, available orchestrator pools. It'll look for that model, and I believe it prefers warm. So if it finds an orchestrator advertising a
That's a
cold
different
model,
issue too.
then it will when it sends the
So
request,
I
I
was
think
saying,
is when it actually
we've
loads it.
noticed, when it sends a request, and then okay, because I mean, I've noticed that as long as there's orcs in the warm pool, or I forget all the terms, session pool or something like that, as long whatever the warm one is, if there's an orc that's already in there, cold models never, or an orc with a model loaded cold's never getting chosen. So so I mean, as far as that goes, I mean, like pretty much cold model only gets selected if there's no one else running it. And at least the way it's working right now, I'm seeing in real world. I mean, rather than Brad running all the upscale models he has where he's the only one. I don't know that I've ever seen anyone get picked just naturally that has a cold model when there's warm models on the network, which is pretty much most models. And then I was curious to know, because what was that?
In principle, a cold model is not loaded and would only be selected
Right.
if there are no warm models, and that should, I say should here because I know there's been some back and forth over the implementation.
Yeah, no,
I'm not even sure if the PR that's merged. I know there was one a week or two ago that was waiting to resolve some of these things. But ideally, that cold model that was pinged would now transition to a warm state, and that would be handling those requests. And so there's just to disambiguate.
So there's a PR so that
a loaded cold model, a cold model that has been loaded is now warm.
okay, because right now it's still like advertised as cold, at least from what I'm seeing. It looks like yeah, I mean, even if a cold model is loaded, it still shows as a cold model, so you'll end up even though you're loaded and ready to go, you're still cold as far as the gateway is concerned, so you're not going to get chosen for that, which seems again inefficient. But if that's something that's being addressed, that's good to hear.
Behavior that needs to be addressed for sure.
Okay, those were really my that covers pretty much everything I was curious about. Appreciate it, guys.
We have
more positive responses there. John, you had something to add?
Oh yeah. So we've seen issues with like timeouts when loading cold containers. There's a lot of things that can go wrong when an orchestrator needs to load a cold container. Then you have some models that they take a very long time to load, maybe too long. So one of the improvements we've been looking at is providing a quicker, I should say, quicker status endpoint as the container starts up, so that the orchestrator checks and is aware of the status of the runner worker, if that makes sense. Imagine the case where you try to load a cold model, you immediately run at it GPU memory, and it just crashes the container. The problem there is the orchestrator just keeps waiting for the model to talk to it, and so there's no that condition isn't handled very gracefully. So generally, most people running warm models right now just because the flakiness, so to speak, with that process. So that's one of the enhancements we're looking at as well.
Yeah, because we've definitely seen that, like when we're trying to force a job to a machine with a cold model just to see how long does it take, it's not uncommon for it to fail, whether it's a timeout or actually I don't even know all the reasons that it may fail, but it's pretty common for a cold model just to not work at all. Somewhat orchestrator dependent, but I don't know if it's orchestrator like specific or, I mean, I don't know if it's the way the orchestrator is set up or but yeah, we don't have good luck with cold models right now. I mean, but at least our theory is that if it's it may fail one time, but once it's loaded, if we like hit it again soon enough and it's still in memory, then we can get a square back from them. But that's not a hard and fast rule. It's just kind of an observation.
That's good feedback. We'll keep working on that. Like I said, the solution we're kind of looking at is, or the problem, main problem we see is the container that's the runner, right, the worker that's doing the work. It puts up a health status endpoint, but it only exposes that after the model's fully loaded. So we can't tell, the status of the loading until it's fully loaded. So if we can expose that earlier when it starts up, we'll be able to gather data and respond accordingly.
Oh, that's interesting. Yeah, we've noticed Brad's stuff tends to load no problem, but very flaky otherwise with most orchestrators. I don't know if he's running a special branch or his own fork or something like that, but just for whatever that's worth, if it helps any troubleshooting.
I think he has a lot of warm models.
Oh, yeah, that too. But I'm just saying, like on things where we know they're cold,
Really?
he tends to pass those. Yeah, it's pretty hit or miss, almost always, most likely miss on most most orgs that have cold models.
Right.
Yeah, so we're hoping to get more info on that, but right now it's just initial observation.
Yeah, thanks for the feedback on that.
All right, just to wrap up,
No problem. We should have more stuff soon.
did we cover?
Go ahead, Titan. Sorry.
Did we cover your topics around when do cold models get loaded and happens when they're loaded?
Yes.
So I guess so. I might have missed it. What happens when it's loaded? Does it become the warm model? Like, how long does it stay loaded for?
Yeah, that's right. So as Peter mentioned, once a model's loaded from cold to warm, it's in the warm pool at that point.
Right. And does the other model become cold?
I don't think we have any case where we unload the models, and that may be another enhancement that we need, or maybe someone has more experience there. But yeah, I think the idea would be
Oh, that might be
ideally.
why we get.
Right.
That could be why models or why cold will fail for a lot of times is if nothing's getting unloaded and it continually tries to load a new model onto something that's out of memory, then that makes a lot of sense.
Yeah, I
Never
need to
even
take
thought
a
about that.
closer look at it before I speak authoritatively on it. But because I've seen code in the runner side where it will, where it could unload, but I haven't ever seen it actually do that. And another thought that we had was this is sort of a re-architecture of where we are today. But each container could be for a pipeline, and the container could load and unload models dynamically. That way you wouldn't have to start a whole new container for every model. That's been sort of an idea that could maybe fit into that model loading solution a little better. But
I just want to chime in with a little, this is sort of longer term philosophical context here. I think what we're dancing around is that ultimately there needs to be an incentivization mechanism to keep models loaded. Like, regardless of how it looks technically, there's no real reason for an orchestrator to keep a model downloaded that it's not running on a regular basis. So, like, A, it has to unload. B, if gateways and gateway providers want that model to be available, there needs to be some sort of incentivization there. This could look like another job type or something similar. I think there's work to be done there, but yeah, ultimately, I kind of believe there has to be incentivization here.
Is the goal to have an orchestrator node, like a GPU specifically, to be loaded with one warm and like a trailing 10 models that are cold, that it gives more capabilities to the network? Or like what's kind of the long-term view on cold loading?
Simply put, that we should minimize it. But to answer the specific question, I think we're headed for a world where, for some common models, right, they're very fungible. Like, if you have llama loaded, you've got llama loaded, and like that winds up being a really common capability that users of the network want to take advantage of. But I also think that you have a very, very long tail, with significant usage of custom models and custom workflows, including workflows that include multiple models but are executed on a single worker or something like that. Uh, those workflows will need support. So to answer your question, no, I don't really expect that, like, you're gonna, like, each orchestrator is gonna have one model loaded and that's it, right? I think it's a much more complex situation.
Complex, you say? What else is new? Yeah, no, that's interesting. Okay, so I mean, and models keep popping out pretty regularly, and demand shifts quite a bit. I guess we're still exploring actual implementation of it. I guess more from like a broader perspective, how much do you see orchestrators deep in the weeds of selecting models versus like having it automated or having some sort of like plan to offer a more, basic. I don't even know how to explain what I'm saying right now. Like, how much is this going to be abstracted away, or how much of it is going to be dependent on the orchestrator doing their research and selecting the models?
I would suggest that it should be almost entirely automated. There may be a slight point of intervention for orchestrators around like setting capacity and deciding what specifically you want to offer. For example, if you want to dedicate resources in a certain fashion but not another fashion, and like maybe there's a place for orchestrators to weigh in the weeds there. But in terms of like the basic process of how models are selected, I don't think it really makes a lot of sense for orchestrators to be like deeply in the technical details of that decision making. I think that if they were, it would reduce the velocity of the marketplace and decrease the likelihood that a given gateway is able to find the capacity necessary to execute the jobs that they want to execute.
Okay, so here's another take. So maybe I'm paraphrasing it. Correct me if I'm wrong, but it sounds like, the orchestrator shouldn't be bogged down with details of loading and managing cold, hot, and which models and these kinds of things. And maybe that could be abstracted away so that the orchestrator can spend more time on business operations, finding hardware, setting market prices, doing all the other things an orchestrator needs to do to keep a healthy network.
Right. You could imagine in a scenario where, when they're onboarding and periodically as they add new hardwares and conduct maintenance, orchestrators run a script that looks at the hardware and says, okay, you've got this hardware and this much VRAM and this much RAM, and therefore you can support these model types. Do you want to serve the most popular 10 models on the network based on these criteria? Okay, cool. That's a reasonable default. Or do you want to select specific models? That's one vision for how it could look. The exact level of abstraction, I think, is going to depend a little bit on the implementation, but I think fundamentally there needs to be some level of abstraction.
Definitely. Yeah, I think as a AI operator myself, like I'd probably rather spend more time figuring out pricing and being competitive and trying to offer a really good service than to dig so deep in the weeds of how to load which cold load models to load and how performant they are. Hand that off to the engineers who could better figure out a solution. That's cool.
As a kind of contrasting perspective and idea, I had kind of envisioned a bit more of the AI operator working as kind of a how would I say this? Like, as if the network's a marketplace and they're actually completely in charge of, and I'm not saying that this is exclusive to what Hunter was saying, but I could see myself engaging more on the level where I want to optimize the models that I'm running. And those are the models that I'm, specifically looking at price of what other people are offering. And other people's prices may determine which models I actually do load. Maybe I could run other models instead because I don't feel like I could charge less than somebody else who has a bunch of those models on the market. So I think that the orchestrator's involvement in choosing which models to provide actually creates an interesting scenario for just optimizing across the network for how to serve the most and best, fastest model for what's in demand.
Yeah, I definitely hear this. I think this is kind of the classic debate of like how managed the marketplace should be. And I think there are really, really legitimate arguments on both sides. Well, I think one, like the situation you're describing requires providers, like gateway providers, to be significantly more engaged with specific orchestrators rather than treating selection as a way of abstracting that work. Whereas the scenario that I described it implies a more managed marketplace where gateways don't have to be like really engaging with orchestrators and can just kind of throw the request over the wall at the network and get it done. I think both are really, really valid, and there's probably valid reasons to go in to support both. Yeah.
I think one interesting part of it as well is that for either to work, I mean, we need more visibility than we have today into, or at least publicly, and for all orchestrators, what types of requests are being made and what capacity. I know we have some dashboards up, but I don't know if we've really pushed those out to the public. And I'd argue that there are probably less confusing ways to present that information as a set of choices for an orchestrator to make.
Yeah, I think we've definitely gone on a tangent here. This is great. We went from when do cold models get loaded, and once they're modeled, how do they stay cold, to philosophical questions around marketplaces and future of the AI model debate. So it's awesome. Cool. I think we'll conclude that topic. Anyone else want to chime in on kind of the loading of the models, picking of the models, any of the AI pipeline stuff? Just a quick comment here. There should be an option to manually decide which models to load, and also some automated solution. In my honest opinion, at the scale of the whole network, automated models will be more efficient to squeeze the most out of our GPUs and therefore offer the cheapest price per inference. Good perspective. Peter says, I agree. Says, agreed. Any other comments? Papa Bear, do we answer your questions? Sorry, that was actually your topic. Kind of kept going. Got gruesome legs. Do we answer your topic?
Oh yeah. Yep, and then some. Thanks.
Cool. Okay, let's continue on. John, let's head over to your topic, which is feedback for the the Livepeer AI docs. Tell us what feedback you're looking for. Give us an idea of what your topic is.
Sure. So I've been helping out with some questions in the AI video chat. More orchestrators are coming online, and we kind of get the same questions, come up a lot. I've been looking for some knowledge gaps. One of the things that our team put together recently was a model stacking guide, and I've been looking to maybe just get that put into our official Livepeer docs, and that might help orchestrators, load multiple models. It kind of gets to solving our model availability problem in a little bit different way. But I think it's a useful thing. I'm also looking for, any feedback around just pain points that people have had, stuff that we can add to the docs. One thing I've thought a lot about is adding like how much GPU memory different models might use, and kind of building that into the stacking guide so that we can avoid like overloading orchestrators. So what I see a lot of is if you you can load these models, but then the memory usage will grow a little bit over time, and so that ends up becoming an issue as well. So those are some areas that I saw that we could improve on. It sounds like the cold model loading might be a good area to add some detail to it. Even as we start to document some of this stuff, a lot of times we'll find the actual technical problem and solve it as we go, too. So, yeah, if anyone has anything that you want added to the docs or stuff you've seen posted, like random knowledge floating around, don't really have like a form or anything you could submit, but you could send some stuff to me or the AI team. We can try to get that added to the docs. So we've done a lot of development over the past year, and then there's certain areas that are just not wrote down yet.
Yeah, definitely. As for the I did start this a long time ago. This is the docs for how much memory is being used by each model. Might be a bit outdated now, but we could definitely clean this up and make it a more streamlined process so that we can easily reference how many gigs of RAM needed for each model, and maybe do some more testing to figure out when it's out or what they max out
Thank
at.
you. Yeah, that's a good start.
Yeah,
Yeah, that's what I was thinking too. We can put some parameters on these models and kind of max them out and see where the maximum usage is. And that may change over time as we add more features like LoRa's and things like that. But yeah, I think that would be good to give orchestrators an idea of whether they're going to need 5 gigs or 12 gigs or whichever for different models.
Are we? I guess that's a good question, because when I initially did all this benchmarking, I was looking at what models did how much, and then figuring out optimizations of like reducing RAM at the sacrifice of speed. So I'm kind of curious as to like, there was this question back in the beginning of like, do we optimize for speed or RAM or availability or whatever? Sounds like speed is pretty important. So all the like the chunking and the sequential offloading and all that stuff seems to kind of fallen by the wayside because people care about speed. But like I'm thinking about the Flux model, the Flux Dev model. Like we only have one GPU on the network that can handle it because it's 39 gigs of RAM. But with sequential offloading, your average 3090 or 4090 could definitely handle it, right? But we haven't implemented that as a flag. I'm wondering, like, do we want to, include larger models that require more RAM? We can just do it slower with these flags. Do we want to focus on that, or we still want to focus on speed?
That's a good question. On the sequential offloading, I'm not too familiar with it. It kind of you mentioned 3090s. It reminds me of the NVLink technology, but I guess it might be something different.
Yeah, there's just a couple of things: sequential offloading, chunking, and then there's
yeah,
CPU offload. There's offload CPU, sequential offloading, and chunking. Like 3 optimizations.
Yeah, I'm familiar with chunking. There are some optimizations coming for the audio to text pipeline. There's a PR out there waiting to merge. When Rick gets back, we'll just look that over once more. It's a good example of that. And sometimes, depending on the input, you might use a different size chunk. For example, with the audio to text, if the audio file is less than 30 seconds, there's a different chunk value that's optimal to use. But if it's over 30 seconds, there's a different number. And right now, those are just hard coded. So I think there's some optimizations we can do just on what type of file size or what the request parameters are.
One comment for me. Sorry, can I interject?
Yes, go ahead.
So one thing I'm learning from the startup program is that if the ecosystem wants to have high demand companies or folks on Livepeer AI, the transactions per second is going to be really important. And right now, as the network stands, like we've struggled to get above a certain amount. I think it's like 100 transactions per or requests per second. So I don't know if that like goes more into this conversation or not, but that's a big piece of what I'm seeing. And then, you know, if we have all these different models, or if people want to put on their custom models, how do we serve all that demand in a adequate time for them to like process their inferences? So I think that's like a big question. I don't know the answer, but just thought I'd share.
Interesting point of view, which is transactions per second. Could you explain more what you mean by transactions per second? Like, are the servers getting overloaded and then they're queuing so you can't get through them fast enough, or they're not getting the responses quick enough from the actual inference time?
So it's more that currently, so like I guess the examples, if you're using AWS, right, for AI, for inferences or for compute, you know, of course they have like, you buy the amount of, I don't know how it works, but I think you buy per inference, so it's like a certain cost, and you do like 1 million, right, and then they just quickly serve you at the speed you choose. I haven't used, this is my understanding from like startups talking to me, but they, you know, so it's like if you have this large amount that you want to like, you know, get inferences on, and they want to push, let's say, you know, like 1 million images, it's like the network at its current juncture can't deal with that. And then the question is, okay, well, if we have, you know, all these different pipelines, let's say, you know, like text image, and then like the SAM2 and all these other things, how do orchestrators switch between the demand? And then if like orchestrators like are just all doing SAM2 models, then no one's serving the other, and there's like one request waiting. I don't know the details of like how the switching will occur, but I think that's going to be pretty important, especially if we have like, let's say there's like 30, right, pipelines on the network, that all are having like decent usage. The picture becomes like super complicated in that way. Or maybe we just limit it to a few pipelines, and, you know, for custom folks, it's just like tough cookies. Like, you know, we don't serve that yet. I don't know if people have thoughts, but that's kind of something I'm seeing.
Yeah, so I just want to dig in a little. You said, you know, if they've got 1 million requests, they want to pump them all through at the same time. So what you're saying, like all what I'm thinking is like, so a lot of GPUs run out of memory. So let's say you've got a 15 gig model, right? And you need a minimum 16 gig card to run it, right? So that means all the 8 gig cards are out. They can't run this thing, right? It's just not available, right? So what you can do is out of your 1 million requests, you know, you can handle, you know, 100, because you only have, you know, 116 gig GPUs, right? And then so you have to wait. You have to probably either queue them or something, right? Like, you can only handle 100. If you use like sequential offloading, like this flag, it reduces it half, right? So you only need like 7 gigs of RAM. So it unlocks all the 8 gig RAMs you have. So now, and there's a lot more 8 gig RAMs cards than there is 16, right? So you know, instead of just handling 100 requests of your 1 million, you can now handle 500 requests, right? However, the trade-off is it takes twice as long, right? So your 5-second inference time turns to 10 seconds, right?
Mm-hmm.
So from the people you're seeing, are they okay with the 10-second inference time, but many more requests get done, or do they still want that fast inference time at 5 seconds, but you don't get to pipe them all through in one transaction?
Yeah, so I think with, you know, the kind of startup program that I'm running, and we're gonna, you know, yeah. Anyway, so the startup program I'm running, like what I'm seeing is, people are ideologically aligned with decentralization, right? They say we want to use Livepeer and we want to push as much demand to the network as we can, right? So there's ideological alignment, which makes them like okay if it's delivered slower. But when you talk about like at scale, right? So if these startups mature and need reliable inferences, the question is like how does our network deliver that? And let's say they're okay if it's a little bit slower than a centralized compute entity like AWS. Let's say they're like, I don't know, it only takes them 2 seconds. I don't know how long it actually takes them, but it only takes them 2 seconds and takes 10 for us. But it's almost like as we mature, there's a tolerance there and a need to make the Livepeer AI attractive to those who want to pump scale on the network. I don't know if that's clear, but yeah.
Right. So you're saying that there's hesitation because people are afraid of scaling issues.
Correct. So right now, like, we, even with the demand generated from Supermodel, which is the, folks I saw in general talking about the spike that everybody saw, right? That was just like the test run for Supermodel. The issue is like, one, can the network sustain that? Right now, I don't think we even have enough supply. We had to like spin up. I think the AISP had to spin up stuff. But regardless, like, how do we actually get enough, like, orchestrators who are supplying compute? And then how do we make sure that time to delivering those inferences back is quick enough for them to actually like make a meaningful pipeline? So Livepeer isn't like the bottleneck for them. And then, as we continue to get on partners who are wanting to use the network, and they have like all these inference demands, how do we start to like make it attractive for them to stay and retain those folks interested in Livepeer AI rather than them churning and saying, well, it's not delivering it fast enough? More general question. This is more medium term, but I thought it's something interesting that I've been thinking about as I've been working with the startups.
No, it's you're like exactly what we need to base. This type of feedback is critical to us because we could sit here all day and like talk about how to do things, but if we actually get feedback from the end user on what they want, it's like, oh, that can change our plan a lot, right? So
yeah, and again, it's a small sample size, right? There's only 8 startups in the program, but I would say from that sample size, that small sample size, take that into account when you're thinking of the picture. But with an N at 8, right? There's okay, well, we want reliable inference, and we want to do high throughput, and can Livepeer do that for us? In a way that's like, there's no downtime. And then if you think about that, just like, let's say you double that number, it's 16, and then there's 5 different pipelines that need a similar amount of demand, right? How do y'all as orchestrators manage that, figure that out, serve those clients reliably? I assume that there's like this market making, right? There's a price component of like, which is the most valuable, right? Which delivers the most value to orchestrators, but also even for smaller fries, like how do we still serve them if they're doing like text image, which might not be super valuable, but or it doesn't take a lot of compute, but is still like something we want to serve to folks.
I want to add to that. I've thought a bit about on the gateway side. Could we have some type of message queuing or queuing of the requests? Today, it's pretty much a 1-for-1. The orchestrator could send out work to. The gateway could send out work to multiple orchestrators, but if it has to send a lot of requests to one orchestrator, it can get overloaded. So there's sort of this limit to the network and what it can handle based on how many orchestrators are running the model you're asking for, the pipeline. So this idea I had was if the gateway could kind of keep track of these as like job jobs that it would continue polling the network until there's availability and then send the work through, something like that. It might also be useful for longer running requests. We were looking at some other inference pipelines that require like inference state, like the SAM2 video. So you could kind of have like a job status you could get back, if that makes sense. And if it may help solve that scaling problem, but it's a pretty large change. And there's also been talk about maybe SDK is a better place for that, but I would just encourage you to think about this, that how the gateway interacts with the orchestrator and how much that can scale as it is today. So there's sort of a limit there. Does that make sense? Sort of like a job queue. You submit an inference job, you get a response back immediately, and then you can check the status of it, or maybe even like a webhook or something.
Right. Cool. Yeah, no, there's definitely, yeah. Let's read some of the comments. Yeah, this is here is where automated loading algos should kick in. The last batch, the bottleneck was the gateway internet bandwidth. So it sounds like it wasn't even the issue with the GPUs itself, but rather the gateway was having bandwidth with the bandwidth issues. Batches were transcoded in a few seconds, but to push them back to the gateway server, it took them 40 seconds. Mike also says the Livepeer AI subnet is still very early. The capacity and throughput concerns are still evolving. It's kind of the chicken or the egg. Supply will come when demand comes. Go. You got to see iPhone on the shelf before you buy it, so supply first. Point of view. From the growth angle, we need to think about how to attract that supply / advertise the rewards. Mike replies, orcs won't provision expensive GPUs if there's not measurable demand that is sustained.
It gets hard, right? Like the chicken and egg situation. I'm seeing like that circle going round and round of, from my end, right? Like the programs I'm developing, like we need to get high quality folks to continue to push demand to the network. And the flip side of it is you got to work on that, but then we have to make sure the supply is consistent enough and meaningful enough where people say, oh, wow, there's like slack to pick up. But then from the startup's angle, it's like, do they want to wait for that slack to be picked up? So how do I, or, the community at large, help bridge that, that moment?
Yes, so I think that it's a great point, and I also want to chime in here a little bit from a gateway provider perspective. So the challenge here is basically like, yeah, a gateway provider can go out and solicit this demand, but until the network can support it, that gateway provider is basically going to have to spin up its own capacity and ensure that the traffic is adequately served, which means that it's not going to hit the network until the gateway provider feels confident that the network can serve it. Because otherwise, the customers that come in are going to churn when they see unreliability. So it's really a problem on both sides. And I know that this isn't the solution, and this is again a classic marketplace problem. I think like there has to be a little bit of risk assumed on both sides. I also think that an automated and incentivized mechanism for model downloading, especially for in-demand models, would be enormously helpful here.
Yeah, totally.
Right. Cool. Any other topics or questions we'd like to cover? Oh, I think your very last topic was the demo day. Can you tell us a little bit about that?
Yes. So speaking of demand on the network, we are wrapping up the first cohort of the startup program, the AI startup program, on October 9th, 12 p.m. EST. I will post the Luma in. Thanks for coming out, Hunter. I'll post the Luma really quick in chat. I posted it earlier, but essentially we're doing a live stream. Hopefully we can live stream it to each location, so like Discord, Twitter, YouTube, and also be live streamed through a link on like Livepeer TV. But essentially, there's going to be the 8 startups, and we're going to be presenting their integrations on Livepeer AI, what they've been doing the last 3 months, the demand they've generated, and what their kind of future plans are, and how people can get more involved in their projects if they're interested, or potentially if there are investors who want to, talk about raises or seed rounds or those type of things. That will also be welcome. So super excited. It's been a lot of work, but we're nearing the end, and I'm excited for the community to see all the startups. And of course, if you can't catch it live, it will be recorded, so you can catch it async, but it's going to be fun. We're going to have a live joke race competition where people can vote for their favorite project. So definitely don't want to miss that. It should be a really exciting time. So yeah, that's all I really had to share. I don't know, been a lot of work, so I'm excited for it.
Very cool. All right. Any other topics or questions before we sign off? All right. Well, with that being said, I'd like to thank everyone for being here and making Livepeer the open and decentralized video infrastructure for the world. Appreciate your time, and we'll see you all next week. Cheers.
Bye, y'all.
Bye.
So